This problem is related to indices. We have to determine the Miller indices. Miller indices are the reciprocals of intercepts of the plane, crystal plane, with the three axes x, y, and z. Here in this problem, the intercepts of the crystal plane are given, and the values are 3a, 2b, and 6c. We have to determine the Miller indices here. So these values 3a, 2b, and 6c are the intercepts which are given expressed in terms of parameters of the unit cell. A, B, C are the parameters of the unit cell. They are expressed like this, and these are the intercepts. So first of all, to determine the Miller index number, the first step is, so we consider these values as the intercepts PA, QB, and RC. So these are the intercepts of the plane, given plane. So when you write like this, here these values are given as 3a. We have to write in coordinate form here, and 2b and 6c. So these are the values here. So these values are given, and here, so we can write the simply PQR values here as the ratio. So when you write as ratio here, P is to Q is to R equals to 3 is to 2 is to 6 here. So these are the intercepts. Now we are going to calculate HKL values, Miller index numbers. So Miller indices are the reciprocals of PQR values here. So we have to write down like that. So we will write like this: H, K, and L. So which are equal to 1 by P and 1 by Q and 1 by R. So these are the reciprocals. So to calculate HKL values, we have to take the reciprocals of 3a, 2b, and 6c. So we'll write the ratio H, K, L. So this is the ratio of the fractions here. These are the fractions here. So we'll write like them as here 1 by P is to 1 by Q is to 1 by R. Now we substitute PQR values here. H is to Q is to L. So which is equal to here 1 by P means 1 by 2 is to 1 by 3 is to 1 by 6. And the next step is we have to take the LCM for the denominator values. In the denominator we have 2, 3 and 6. So we have to take the denominator value here. So LCM for that one is LCM of 2, 3 and 6. So this equals to 6. Then multiply each fraction with 6. So after multiplying each fraction with 6, and we have to convert into small integers for that. So the next step is we have to multiply 1 by 2, 1 by 3, 1 by 6 with 6. So this will be H is to K is to L. So this is the Miller indices, ratio of Miller indices. This is equals to 1 by 2 multiplied by LCM. 6 is to 1 by 3 multiplied by 6, which is equal to LCM, and 1 by 6 multiplied by 6. So you will get the value here H is to K is to L equals to, here it will be 6 by 2 equals to 3. So you will get 3, and here you will get 6 by 3, 2, and you will get 1. So if you write in a coordinate form HKL values as, so this equals to, this will be here 3, 2 and 1. So this is the way to find out the determining the Miller index numbers. I repeat once again. These are the values 3a, 2b, and 6c, the intercepts of the given plane, and these are the intercepts with respect to xyz axis, and which are expressed in terms of ABC values, which are parameters of the unit cell. For that, first we write like this: PA, QB, RC, proportional to these are 3A, 2B, and 6C. So we'll take the PQR values, the ratio P is to Q is to R equals to 3 is to 2 is to 6. And later on, we take reciprocals of 1 by P, 1 by Q, 1 by R as HKL values. And we take again the ratio H is to Q is to L equals 1 by PQ is to 1 by Q is to 1 by R. And then in the denominator, we have these values 2, 3, and 6. So we have to take the least common multiplier, LCM. So the LCM of 2, 3, and 6 is 6. Then multiply each fraction with the 6 here. So HKL equals to 1 by 2 into 6, 1 by 3 into 6, 1 by 6 into 11. So you will get 3, 2, 1 as the Miller index numbers. So this is the way how to find out the Miller index numbers.